Load level, load level, load level. Let's take a look. Indigo, please take me to the load level function, please. Thank you. First, print to console. Now, if you remember before, we had the function open console up above. Well, this function that we've just looked at here will print to the console. Any print statement or any cursor statement will now be applied to a window separate from the Dart Basic main window, which we'll take a look at when we test the program. So here, from now on, this print statement, 2 lines down, will not be displayed on the Dart Basic window, but it will be displayed on the console, and there will be no need to call any sync commands or anything. This also requires the Matrix 1 utility plugin, so beware. Make sure you've got it installed. Here we have a level state. This is the double integer variable that has been set to 0. So every time we load a level, its state is defaulted to nothing. None of the bits are true, all of them are false. The first thing we do is load the level. I've got a literal variable here, a literal value of testcourse.dbo, Dart Basic object, and its object number is going to be course, which is 1. We're going to scale the level to a scale of 10 and making it a lot smaller. Now in 3D World Studio the levels are pretty large in nature. The units start from 1 and go up in multiples of 2. So generally the levels there are really large. Doesn't really deal with floating point positions. Everything's all in integers. However, in Dart Basic the points and the positions are in floating point variables. So I've simply scaled down the level, and the Dart Dynamics plugin will not have any issues with producing the physics object, with the scaled object that is. Now we need to set up the rigid level object, which is down here. Now this is going to set up what's called a triangle mesh, which will indicate to the Dart Dynamics plugin what objects need to be collisional. Any dynamic rigid bodies will collide and bounce off of these objects. And this particular type of object, the triangle mesh, uses its polygon structure to implement the collision rather than a bounding box or a bounding sphere. So this is similar to the Dart Basic commands, set object collision to polygons. Now in this process I've done it for demonstration purposes. I've created an object from the level object ID passed earlier, which is basically the object loaded from the disk, and we're making a mesh from it, and we're producing a triangle mesh from the mesh, from the Dart Basic mesh. However, in a real game you'd want to have the dynamic triangle mesh saved to disk, so that the program doesn't have to calculate all of the polygons, which needs to affect the collision system. However, here we're producing this collision system every time we load the level from disk. We're creating a mesh from the object, and we're making another object from the mesh we created. So we've made a duplicate. Why have we made a duplicate? We've done it this way because we need to have this object used as a basic structure of the physics system, and we need to get rid of all of the empty limbs and all of the limbs without any mesh information, such as the point entities, and we're creating it with a single limb object. It makes it nice and easy for the Dart Dynamics system to produce our cooked triangle mesh. So here the temporary object produced from the copy of the level has been used to cook the triangle mesh. Again, this is something you would do once and save the result to file, as you'll see in the documentation of the Dart Dynamics plugin. However, for demonstration purposes, every time you load the game, we're going to produce our triangle mesh on the fly. And at the end, we make the mesh from the cooked information. So it takes two steps: cook triangle mesh, make triangle mesh. Once that's done, and we return a 1 or non-zero variable, a non-zero return value, then everything's fine. Otherwise, if it returns 0, we have an error, failed to activate triangle mesh. Report error is a function supplied by the Matrix 1 utility program, so be sure to have that, as I said before, be sure to have that installed, otherwise this will not work. Going back, we have here below this call setup level entities. Let's take a look at that. Now the entities are what we discussed earlier. Remember, we looked at the point entities showcased in the Notepad++ document, which outlines to the 3D Roll Studio program what entities should exist in our game. So this is where we actually make our entities available to our program. We have to do a query of all of the limbs in the level, all of the sub-objects in the level. To do this, we do a for loop, and we obtain the name of the limb, and we convert the limb to a lowercase letter. Here we have the fast lower function, which is a Matrix 1 utility alternative, which converts all of the name into lowercase characters very quickly. And here we have the limb name and the limb number, which corresponds to the current iteration of the for loop, L in this case, where N is the number of limbs in the object. So from 1 to N, for each limb store the limb's name in lowercase and print it. Now we know that we are printing to the console, so this is information that's going to be displayed for development purposes to make sure that our limb names are what we expect them to be. Here we have a search in the name for start position. Now the limb name is going to actually store the entire code for the entity. All I want to find out is whether or not that code contains the term start position, which is why we've done an in-string search with this function here. So we couldn't just write if limb name equals start position. That will not work because, as I said, the limb name is going to store the actual entity point class code. So let's see whether the code has the term start position. If it doesn't, then do not do the following. If it does, proceed. If it proceeds, we're going to store our start position in the location of that limb. As you can see here, this is our start position, which is based upon the vec type using the UDT that we made earlier, which stores the vector location of the limb, and we output that position on the console. If something goes wrong, we can just take a look at the console and see what's happening. Here it tells us what position the start position is at. I've created a function also, vec with a $sign at the end, which returns a string representation of the vector according to the supplied vec type object, and a number of decimal places to decorate the string. If the object or the limb doesn't have the start position object or entity name, check to see if it has the whole position entity name. If it does, store the whole position at that location, and do the same. Output the position of the whole position to the console, and that will do. Keep on going throughout the whole level. In your games you might want to have more than one whole position or start position, alternatives, or all sorts of entities, so you keep on going and keep doing something similar. You could also create a key value system which can read the properties that you've created inside of your entity class, which I've done in my video game, but for this, just having these positions stored from the entity's name and location and the in position will suffice. So now all of our entities have been set up, and we need to take a look at the level state here. Once we get the start position, store in the level state the set bit of start position set. So at the position of start position set, which is position number 3, set that bit to true and store the result of the level state into the level state variable. Likewise with the whole position. And now back to our load level function. If the start position has been set and the whole position has been set, which has been carried out by the bit-get function of the Matrix 1 utility plugin, proceed by setting the level loaded bit to true. Print back to the window and return back to our load level location here. Now in the next part of the video, we'll take a look at how the game actually runs, how it all works, what goes into getting the dynamics functions to do what we need, and what goes into this update game function and all the rest of it. So see you in the next part.